Hi, welcome back. My name is Dev, and in this video, I will walk you through the contribution guidelines of Bricks. What is Bricks? It is a library of off-the-shelf natural language processing enrichments that can be used in a project or in a directory in Refinery. Well, if you don't have any idea about Refinery, check out our previous videos. Bricks will make it easier for developers to build better products, and hence the name. So, without any further delay, let's dive into it. So the first thing that we want to do is to clone the repository. For that, we can go onto the Kern AI GitHub page and we can look for the Bricks repository. Here we already can see the Bricks repository and we will clone it. So on the terminal, I'll do git clone. Good. Now we have cloned the repository. So we can go into the directory, and if we do git branch, you'll see that we are in the main branch. Now, the idea is to keep it as standardized as possible. If we were to implement a new endpoint or new module, then we create a separate branch for that. So for example, let's say if we take language detection as our base module to walk through this video, then we can create a separate branch. So git checkout. So we have switched to a new branch and we will synchronize it with the main so that it tracks the main branch. Sorry about that. All right, and now we will push the contents. Nice. So now if we do git branch all, so here we can see we are locally in the language detection video. That is the local repository, and we have the remote repository set up as well, language detection video. And as you can already see, we have switched to this new branch. So now let's say we are going through the language detection example. So the next thing that we want to do is to create an issue for this. So if we go onto the issues in the repository and create a new issue. So in here, we can just make the issue language detection and can write a short description like module that detects input text, for example, hello, how are you, which gives the output as English. And then if you already have any Python implementation in mind, you're free to write it. If you do not know how to implement this, do not worry. Smallest to smallest contribution counts. So if you just come up with the idea but don't know how to implement that, we will take care of the implementation. Any ideas are welcome. So then you can create the submit new issue and it will create a new issue. But since we already have the language detection, we will not create the issue. So now we can go into the VS Code editor. In here, we can see there are three folders, basically classifiers, extractors, and generators. So the classifiers, look, as the name suggests, for all the three of them, classifiers summarize a given text into a specific category. So for example, language detection that we'll see in a bit, it takes the input text and it classifies whether the language is English, French, Spanish, German, and so on and so forth. Extractors retrieve specific information from a given text, for example, address, location, phone number, etc. And the generators, they create new content based on a given text. So, for example, if we have a module for correcting spelling mistakes, so we have an input text which is heavily prone to spelling errors, then the module in the generators for spelling correction basically creates the correct, like it returns the corrected text to the best of its accuracy. And in the classifiers, if we go, we have the language detection. So here you can see we already have it specified, like implemented, but for the sake of this video, I will delete this package from here and also wherever it is used. Right, I'll save it like that. Okay, so now we can actually go about writing the functions. But before that, we would want to create a virtual environment. It is highly recommended. So for that, we can do now we have created the virtual environment and let's enter this virtual environment. So now that we are in the virtual environment, so the next thing that we need to do is you have this requirements.txt file, which consists of all the packages and libraries that are used to create the modules. So we are going to install the requirements file. This may take up to a couple of minutes. All right, so we have the requirements files installed. So now we can go about creating our Python package. So we will have a new folder, name it language detection. And in there we have to create an init.py. So this init.py basically contains the code that will be executed when you click the run button on the online platform. So the API basically fetches the output based on the given input by executing the code that will be implemented here. So let's do that. So for this module, we use the langdetect library. Basically, this is the main highlight, which basically helps to classify which language is the given text input is. Then we create the sample. This input example contains the default value that will be displayed when we go on the online platform for this module. So this bit of code basically takes care of implementing the input example onto the online platform. So to keep it synchronized for all the modules with the online platform, basically. And now we can go about creating our language detection function. So one thing to notice here is that the name of the function should be the same as the name of the directory. Um, like there is no there is actually a technical reason for that. Because while publishing the modules, there is another script that reads the directory where the module is stored in, and also the function. So if the name of the directory and the functions are the same, it is kind of easier to iterate over. And after here, so in here, we can actually specify a docstring. I will tell you why that is important. So let's say now can use the attributes from the language detection model class, and here language you can do detect text and basically just return dictionary language. All right, so this is our entire implementation that will be executed on the online platform. One more thing that we can do here is detector factory dot seed equal to 0. Now what this does is basically, let's say you have a small string, basically it's for the small strings. So you have a small string in English, but then the model is not that great in detecting the language. So let's say you have the same input, and every single time you run the same input, uh, it gives a different output. So most of the times it will give the right output on the first go. So just to fix that output, like, for the same input. So if we have the same input over and over again, the output will be fixed, whatever it has shown in the first try. So here we have the init.py. Next, we can go about we create another file, which is the code snippet. Here we will have the Python code that is compatible with the one that you run on Refinery. So it's the same module for language detection, but now this code is implemented so that it can be run on Refinery. And in some cases, it's not too different. For example, for language detection, it won't be too different. But for other cases, there might be 2-3 changes that would be required. So let's go through this. Right, so this is our implementation for the language detection that will work in Refinery. So since the Refinery uses spaCy under the hood, we have to pass the attribute for the record, and then .text will actually give you the text from the record. And then we can pass the detect function that takes in the text and returns the language in which the text is in. Super easy, pretty simple. All right, so now we can create another folder, which is the readme.md. And basically, this is, as the name suggests, just a README file which has a bit of the information about what the module does, what does it use. So basically entails the doc string from the init.py. So the README is basically, as the name suggests, is a small description about what the module does, what libraries does it use, and yeah, it basically tails the description from the doc string that we have presented in the init.py. So basically this doc string is highlighted when we go to the online platform. Let's say for classifiers, there we have the language detection model, and under the language detection model, we would have like a small description that will be taken from this doc string. So as an example, show you, I already have the bricks running. So on the classifiers, we have the, let's say, reading time. So when you see calculate the reading time of a text, it's basically taken from the doc string that we have here. Now the README, it can be a little more detailed than the doc string. So we can write something like, right, so here we have a bit detailed description of what the module does. Save all of these. And lastly, we have the config.py. So this file config.py is basically there to synchronize the modules with the online platform. So there's a script that reads the config.py, and it basically keeps all the modules updated that are published on the online platform. So if we go to this template folder in the same directory, we have a template for the config.py, and we can copy the above two statements, paste here, then from import language detection and input example. Now def get config, then we can copy paste this, and in here in the function name, instead of template, we will have language detection. The input example is there, the data type is text, the issue ID. So when we have created the issue, on GitHub, like it would have its own issue ID. So for example, we have the language detection, it has the issue ID 139. So 139 goes in here. And lastly, we have the last argument, state. So we can have two kinds of state, public or draft. So let's say if we were testing the module and we don't want this module to be published, then we set it to draft. So basically, while publishing the module, the script just skips over this module and publish the rest of them. But if this is set to public, so let's say public, then we have this module published as well on the online, at least on the testing server. So we can save this. Now, last but not the least, we can add the language detection to our routers. This is important because this is the script that is used in testing. So when we run the ubicorn and we it publishes all the modules that are there in your classifiers, basically you have to import all the modules here, otherwise it doesn't read where the module is, and it skips. So on a new terminal, we first enter the virtual environment. So do it, then we can type Kern API reload. So basically now we are in the testing phase to see if our modules are working. Okay, so our application is running now. So now if we go to localhost 8000 dots, here we have the classifiers. We can see language detection popped up. And if we were to try this out, so we can give it like an input text. So for example, hello, how are you? And we execute it. Nice. We have the output as language, English. So it returned a dictionary. And that's exactly what we wanted. So the module passed our test here. This is amazing. So now this is tested in here. We can make one more test to see if this code works on refinery. So we copy the code in here and we can go to the refinery. So on refinery page, either you can create a new attribute. I already have few, so I'll go in here. It was already there. So we have to choose an attribute. So let's say we go for the headline and then we just replace it in here. And we run on 10 samples. And if it throws an error, then it's wrong. It doesn't. It actually shows English for all of them, and it works. So that is awesome already. So the module passed our tests. Now, what is remaining is to commit and push. So we can go back to our terminal and we can add commit, comment like the module git push. So now we have it pushed on the GitHub repository. So if we go to the code, you can see language detection video had recent pushes. And from here, I can create a pull request. When we create the pull request, we also have to leave a comment, which basically says that this module implements issue number, whatever the number of issue was. So it implements this, tested, works fine, or something like that. And then you can create a pull request. We will review the pull request, obviously. And when all the checks are there, all the tests are passed, then we will merge your implementation to the main branch. And there you have it. So that's how you can contribute to the bricks pipeline. And I'll see you in the next video.